Hello, and welcome to the Dreamy Science Lab, your peaceful little pocket of the universe where wonder feels soft and the night quietly cradles you. Before we slip into tonight's journey among the stars, I'd love to hear from you. Where in the world are you tuning in from right now, and what time is it where you are? Drop it in the comments below. I'm always quietly amazed at how many of us are gently floating awake together across so many different time zones. And if tonight's story helps you feel calm or sleepy in the best way, a soft little like and maybe a subscribe would mean the world. It helps other tired souls discover this quiet corner too. Tonight we're going somewhere beautiful. The quiet, mysterious awakening of consciousness, not just in the brain, but woven into the very fabric of reality, emerging from particles, probability, and the silent mathematics beneath existence. I hope it's gentle enough to carry you towards sleep. But if your thoughts decide to stay bright and curious instead, at least you'll gather a few beautiful ideas about how your mind may be connected to the universe itself. So come a little closer, let your shoulders soften, take a slow, unhurried breath. Tonight we're drifting through neurons and nebulae, through quantum fields and flickers of awareness, exploring the possibility that consciousness is not merely produced by the brain, but participates in something far deeper. There's no rush, nothing to solve. The universe has been patient for billions of years. Ready? Let's begin. Take a deep breath. Let yourself settle into this moment. There's nowhere you need to be, nothing you need to do right now. Just be here. Be present. If you're listening to this at night, perhaps you can see stars through your window. If not, close your eyes for a moment and imagine them. Billions of points of light scattered across an infinite canvas of darkness, each one a sun, perhaps with worlds of its own. Galaxies spinning in the cosmic dance that has been going on for billions of years. And here you are, on a small blue planet, orbiting an ordinary star in the outer arm of a spiral galaxy. But you're not just here. You're aware that you're here. You can think about yourself thinking. You can wonder about wondering. This awareness, this consciousness that you possess, is perhaps the most extraordinary phenomenon in the known universe. You can close your eyes and imagine places you've never been. You can remember moments from years ago with startling clarity. You can feel emotions that have no physical form. You can dream. So which is light really? A wave or a particle? The answer, strange as it sounds, is both, or neither. Or perhaps it's something else entirely that can manifest as either depending on how you observe it. Light is fundamentally something that doesn't fit into our everyday categories. It transcends our usual ways of thinking about what things are, and it's not just light. Electrons, atoms, even molecules show this same behavior. Matter itself, at its deepest level, isn't quite what we think it is. Superposition. Here's where things get even stranger. Imagine you flip a coin. While it's spinning in the air, you don't know if it's heads or tails. But the coin itself is either heads or tails at every moment. You just haven't looked yet. Or is it? In the quantum world, particles don't work like classical coins. Before you measure them, they genuinely exist in multiple states at once. An electron doesn't have a definite position. It exists in a superposition, a kind of quantum limbo where all possible positions are real simultaneously. This isn't just about our ignorance. It's not that the electron is really in one place and we just don't know where. According to quantum mechanics, the electron is in a very real sense in multiple places at once. It's a cloud of possibility, a blur of maybe here and maybe there spreading through space. Think of it like a musical chord. When you play 3 notes simultaneously, you're not playing one note or another. All 3 notes are genuinely present at once, creating something richer than any single note could be. A quantum particle in superposition is a bit like that. It's many possibilities playing simultaneously. But here's the kicker. The moment you measure the particle, the moment you look to see where it actually is, the superposition collapses. All the possibilities crystallize into one definite outcome. The electron is suddenly here, not there. One note from the chord rings out and the others vanish. This is called wave function collapse, and it's one of the most puzzling aspects of quantum mechanics. What causes it? Does the act of observation somehow create reality? And if so, what counts as an observation? Hold that thought. We'll come back to it, because it's central to the quantum consciousness theory. Quantum entanglement now for perhaps the strangest quantum phenomenon of all. Imagine 2 dancers who train together for years. Even when separated, they move in perfect synchronization, as if reading each other's minds. They're connected by shared experience, by memory, by a deep understanding of each other's movements. Quantum entanglement is like that, but far more profound and far more mysterious. When 2 particles become entangled through a shared origin or interaction, they remain connected in a deep way. Measure one particle and you instantly know something about the other, no matter how far apart they are. Change the state of one and the other responds, even if they're on opposite sides of the galaxy. This isn't because they're sending signals to each other. The connection is more fundamental than that. The 2 particles, in a very real sense, are not entirely separate. They're part of a single quantum system, even when vast distances separate them. Einstein called this spooky action at a distance, and he didn't like it at all. It seemed to violate everything we know about how the universe works. How can something here be instantly connected to something there, with no time for a signal to pass between them? Yet experiment after experiment has confirmed it. Entanglement is real. Particles can be connected in ways that transcend space and time as we usually understand them. The quantum world is teaching us something profound. Reality at its deepest level is interconnected in ways we're only beginning to understand. Separation, distance, individuality. These might not be as fundamental as they seem. Take a moment with that. Let it sink in. The particles that make up your body, that make up everything around you, are all potentially connected in these quantum ways. The universe at its foundation is not a collection of isolated objects, but a vast web of relationships. This is the world that quantum physics has revealed, a world of uncertainty, of superposition, of connections that defy our usual understanding, a world that behaves more like a dream than like the solid reality we think we know. And now we come to the question that links this strange quantum world to consciousness itself. If the brain is made of quantum particles, could quantum effects play a role in how consciousness works? Could the mystery of the quantum world help explain the mystery of the mind? For decades after quantum mechanics was discovered, most scientists assumed it was irrelevant to biology. The brain, after all, is warm, wet, and messy. Nothing like the ultra-cold, carefully isolated conditions needed for quantum effects in laboratory experiments. Quantum phenomena, scientists believed, were too delicate, too fragile to survive in the chaotic environment of living cells. They would be washed away by heat and noise long before they could influence anything important. The brain, in this view, operates entirely according to classical physics, the physics of everyday objects, of circuits and chemistry, of cause and effect. But a few scientists began to wonder. They looked at the hard problem of consciousness, that seemingly intractable gap between physical processes and subjective experience, and they looked at the strange, almost dreamlike behavior of quantum systems, and they saw intriguing parallels. In quantum mechanics, observation plays a mysterious role. The act of measurement seems to affect reality, collapsing waves of possibility into definite outcomes. Could consciousness itself be what collapses quantum wave functions? Could the observer and the observed be connected in some deep quantum way? In quantum mechanics, particles can exist in superposition, multiple states at once. Could the brain somehow harness this to process multiple possibilities simultaneously? Could quantum superposition be the key to how we hold multiple ideas in mind at once? How we experience the richness of consciousness? In quantum mechanics, entanglement creates instantaneous correlations across space. Could this help explain the unity of consciousness? How your brain binds together information from different regions into a single, coherent experience of the present moment. These were provocative questions, wild speculations, some said. But a few researchers began to take them seriously. One of the first was the physicist Eugene Wigner, who pondered the measurement problem in quantum mechanics. If observation collapses the wave function, he asked, what counts as an observation? Does it require consciousness? If so, consciousness would be playing a fundamental role in the physical universe, not just a byproduct of matter, but something woven into the fabric of reality itself. Later, Roger Penrose, a mathematical physicist and winner of the Nobel Prize, took these ideas further. Penrose argued that consciousness couldn't be fully explained by classical computation, that there was something about conscious understanding, about genuine insight and awareness, that went beyond algorithmic processing. If consciousness wasn't purely computational, Penrose reasoned, perhaps it involved physical processes that classical computers couldn't simulate. Perhaps it involved quantum mechanics. But there was a problem. The brain is noisy, warm, full of water molecules bouncing around. How could delicate quantum effects survive there for more than a fraction of a second? Then Penrose met Stuart Hameroff, an anesthesiologist who had been thinking about consciousness from a different angle. Hameroff had become fascinated by structures inside neurons called microtubules. These are tiny, hollow tubes made of protein, part of the cell's internal skeleton. They're found in all cells, but they're especially abundant in neurons, and they have some interesting properties. Microtubules are highly organized structures. They have a regular crystalline arrangement, and they might, Hameroff thought, be sheltered enough from environmental noise to support quantum effects. When Penrose and Hameroff combined their ideas, a theory was born. They called it orchestrated objective reduction, or ORC-OR for short. It's a mouthful of a name, but the core idea is fascinating. What if consciousness arises from quantum computations inside microtubules? What if these tiny structures serve as quantum computers inside every neuron, processing information in ways that classical neurons alone could not? According to ORC-OR, quantum superpositions can occur within microtubules. Multiple possible states exist simultaneously until they reach a threshold and collapse into a definite state, a moment of conscious experience. These moments happen rapidly, many times per second, giving rise to the continuous stream of consciousness we experience. The theory is speculative, it's controversial. Many neuroscientists are skeptical, but it represents something important, a serious attempt to connect the two greatest mysteries in science, the nature of quantum reality and the nature of consciousness. Whether or not Ochoa is correct, it opened a door. It invited scientists to ask, what if consciousness is quantum? What if the brain really does harness the strange properties of the quantum world? Let's explore this theory more deeply. Let's see what it would mean if it were true. Picture an orchestra. Dozens of musicians, each with their own instrument, each playing their own part. Individually, each musician creates sound, but together, when properly orchestrated, they create something far greater, a symphony that moves the soul. This is the metaphor at the heart of Ochoa. Consciousness, in this view, isn't just neurons firing. It's not just information processing. It's something orchestrated, many quantum states working together, coordinated in precise ways, building toward moments of unified experience. Scientists have mapped the human brain in incredible detail. They can watch neurons firing, measure electrical signals, trace the pathways of thoughts as they move through your neural networks. And yet, despite all this knowledge, there remains a profound mystery at the heart of everything. How does the physical substance of your brain create the inner experience of being you? How do electrical impulses and chemical reactions become the feeling of love, the color red, the taste of chocolate, or the memory of your grandmother's laugh? Tonight, we're going to explore a fascinating possibility, an idea that bridges two of the most mysterious realms of science, the nature of consciousness and the strange behavior of matter at the quantum level. What if your mind is not confined to the 3 pounds of tissue in your skull? So what if consciousness itself operates according to the same quantum principles that govern the deepest levels of reality? What if, in some profound and fundamental way, your thoughts are actually connected to the fabric of the universe itself, the stage? Microtubules. To understand Ochoa, we first need to understand the stage where it all happens, the microtubules. Imagine zooming into a neuron, past the cell membrane, into the cytoplasm, the cellular soup that fills the cell. Here you find an intricate network of tiny tubes, like scaffolding inside a building. These are the microtubules. They're made of proteins called tubulins, arranged in a precise geometric pattern. 13 columns of tubulins spiral around to form a hollow cylinder, each tubulin fitting perfectly with its neighbours. The structure is elegant, repeating, almost crystalline. Each tubulin protein can exist in multiple conformational states, different shapes it can take. Think of them like tiny switches that can flip between on and off positions, and they're electrically active, are influenced by the movement of electrons within them. Now here's what Penrose and Hameroff propose. What if these tubulins don't just flip between classical states? What if they can enter quantum superposition, existing in both states at once? And what if, through quantum entanglement, tubulins across many microtubules become linked? What if they form a vast quantum network spanning the neuron, perhaps even connecting neurons together? If this were possible, the implications would be profound. Each neuron wouldn't just be processing information classically, it would be a quantum computer, able to hold multiple possibilities in superposition, able to explore many computational pathways simultaneously. The performance. Quantum computations. According to Orr, consciousness arises through a process that unfolds in stages. First, tubulins enter superposition. Not just one or two, but vast networks of them, all entangled together. They exist in a quantum state, a superposition of many possible configurations simultaneously. Each configuration represents a different pattern of information, a different possible experience. This quantum state evolves over time, following the laws of quantum mechanics. Different possible configurations interfere with each other, some strengthening, others cancelling out. It's like waves in a pond meeting and creating patterns, some peaks higher, some troughs deeper. But this can't go on forever. Eventually something has to happen. The superposition must resolve into a definite state, which one configuration must become actual. In standard quantum mechanics, this happens when the system is measured or observed. The wave function collapses, but Penrose proposes something different, something he calls objective reduction. According to Penrose, collapse doesn't require an external observer. Instead, it's built into the fabric of reality itself. When a quantum superposition reaches a certain threshold, related to the difference in energy between the superposed states and the curvature of space-time itself, it spontaneously collapses. This might sound wildly abstract, but here's the key insight. If Penrose is right, then the collapse of quantum superpositions is a real physical event, not just a change in our knowledge. And Orshaw proposes that these collapse events are moments of conscious experience. Each collapse is a moment when multiple possibilities crystallize into one definite experience. When the orchestrated quantum state of billions of tubulins across vast networks of microtubules suddenly reduces to a specific pattern. And in that moment, you experience something, a thought, a feeling, a perception, a moment of awareness, the symphony, orchestrated experience. This is why the theory is called orchestrated. The collapse isn't random, it's coordinated, guided by quantum coherence and entanglement, by the overall structure of the quantum state that has been evolving. Imagine thousands of musicians playing together. At any moment, the combined sound they create depends on how their individual notes blend, reinforce, or interfere with each other. The final chord that emerges has a unity, a coherence that no single instrument could produce alone. Similarly, according to Orr, your conscious experience at any moment emerges from the collective quantum state of microtubules across your brain. Different regions, processing different information, all entangled together in one quantum state. When that state collapses, you don't experience separate, isolated bits of information. You experience a unified moment, a coherent now that binds together sights, sounds, thoughts, and feelings into a single experiential whole. This would help explain one of the deepest mysteries of consciousness, the binding problem. How does your brain take information from different senses, different memories, different thought processes, and bind them together into one unified experience? Classical neuroscience struggles with this. Individual neurons fire separately. Information is processed in different brain regions. Yet somehow you experience the present moment as one thing, not a collection of parts, but a unified whole. Quantum entanglement might provide an answer. If microtubules across the brain are entangled, they're not truly separate. They're part of one quantum system, and when that system collapses, it collapses all at once, creating a unified moment of experience. According to Orshaw, this happens many times per second. Each collapse lasts for a fraction of a second, long enough for quantum states to build up, short enough to give you the sense of continuous experience. Your stream of consciousness is really a series of quantum events. It's like frames in a film that blend together into the illusion of continuous motion. It's a beautiful theory, elegant, profound. It suggests that consciousness is not just a side effect of neural computation, but something fundamental, connected to the deepest laws of physics, to the quantum nature of reality itself. But is it true? That's a question we'll return to. First, let's explore some of the fascinating ideas and thought experiments that quantum consciousness theory opens up. Because whether or not the theory is correct, thinking about it reveals deep truths about reality and consciousness. Fascinating thought experiments. Let's pause for a moment and explore some of the thought experiments that quantum mechanics has given us. These aren't just intellectual puzzles, they're windows into the strange nature of reality itself, and they raise profound questions about observation, consciousness, and the role of the observer. Schrödinger's cat, you've probably heard of this one. It's become famous, almost a cultural meme. But let's think about it carefully because it reveals something important. Imagine a cat in a sealed box. Inside the box is a radioactive atom that has a 50% chance of decaying within an hour. If it decays, it triggers a mechanism that releases poison, killing the cat. If it doesn't decay, the cat lives. According to quantum mechanics, before you open the box, the radioactive atom exists in a superposition, both decayed and not decayed at once, and if the atom is in superposition, then so is everything connected to it, the poison mechanism, the poison itself, and disturbingly, the cat. Before you open the box, the cat is both alive and dead. Not either alive or dead, we just don't know which. Actually both. A quantum superposition of life and death. Only when you open the box and observe does the superposition collapse. The cat becomes definitely alive or definitely dead. Erwin Schrödinger created this thought experiment not to celebrate quantum mechanics, but to criticize it. He thought it was absurd that observation could play such a role. A cat can't be both alive and dead. Something must be wrong with our understanding. Yet experiments with quantum systems confirm this basic weirdness. Particles really do exist in superposition until measured. The question is, where does the quantum realm end and the classical world begin? At what scale do things stop being quantum and start being definitely one thing or another? And more troublingly, what counts as an observation? Does it require a conscious observer? Could consciousness itself be what collapses superpositions, turning quantum possibilities into classical reality? The observer effect. This brings us to one of the most controversial aspects of quantum mechanics, the observer effect. In the famous double-slit experiment, particles like electrons are fired at a screen with two slits. If you don't observe which slit each particle goes through, they behave like waves, creating an interference pattern. Multiple particles somehow interfere with themselves, as if each one goes through both slits at once. But if you set up detectors to observe which slit each particle passes through, The interference pattern disappears. The particles start behaving like particles, each going through one slit or the other. The very act of observation changes the outcome. This is the theory of quantum consciousness, and whether it turns out to be true or not, the journey of exploring it reveals something beautiful about both the universe we live in and the mystery of our own awareness. So settle in. Let your mind relax. We're about to embark on a journey through the cosmos and through consciousness itself, a journey that might just change the way you think about thinking. Let's begin with a simple question. What is consciousness? What is consciousness? Close your eyes for a moment. Notice what happens. Even in darkness, there's something happening. You're still here, still aware, still experiencing something. Maybe you hear sounds around you. Maybe you notice your breathing. Maybe thoughts drift through your mind like clouds across a sky. Now, the standard interpretation is that observation means any interaction with a measurement device. It's not about consciousness. It's about physical interaction. The particle interacting with the detector, becoming entangled with it, causing the wave function to decohere. But some interpretations go further. They suggest that consciousness plays a more fundamental role, that the universe exists in quantum superposition until a conscious observer collapses it into definite reality. That observation by a conscious mind is what makes reality real. This is speculative, controversial. Most physicists don't accept it, but it raises fascinating questions. Does reality exist independently of observation? Or is the observer somehow woven into the fabric of reality itself? If quantum consciousness theory is correct, maybe these questions take on new meaning. Maybe consciousness isn't just observing reality. Maybe it's participating in creating it, moment by moment, through quantum processes in the brain. The measurement problem. At the heart of all this is what physicists call the measurement problem. It's a deep puzzle that quantum mechanics raises but doesn't fully answer. The equations of quantum mechanics describe how quantum states evolve over time. They show how superpositions form and develop, and according to these equations, superpositions should persist forever, getting larger and more complex but never collapsing. Yet we never see macroscopic superpositions. We never see a cat that's both alive and dead. We never see a ball that's both here and there. Somehow, somewhere, the quantum superposition collapses into definite classical reality. When? How? Why? These are the questions at the heart of the measurement problem. Different interpretations of quantum mechanics give different answers. Some say there's no collapse at all, that all possibilities remain real in parallel universes. Some say collapse happens through environmental interaction, through decoherence. Some say it requires consciousness. Or-Coar proposes yet another answer, that collapse is objective, built into the laws of physics, related to gravity and space-time geometry, and that these collapse events, when orchestrated in the right way in the brain, are what we experience as consciousness. It's a bold idea, and it suggests something profound, that the mystery of consciousness and the mystery of quantum measurement might be two sides of the same coin, that solving one might help us solve the other. These thought experiments remind us that reality, at its deepest level, is far stranger than our everyday experience suggests, and they hint that consciousness might play a more fundamental role in the universe than we typically imagine. The universe as information. Let's shift perspective for a moment. Let's think about the universe not as matter and energy, but as information and patterns. This might sound abstract, but bear with me, because this way of thinking reveals something beautiful about the connection between consciousness and cosmos. Everything is information. When you look at a tree, what are you really seeing? Light bounces off its leaves, enters your eyes, triggers chemical reactions in your retina. Those reactions generate electrical signals that travel to your brain. Your brain processes these signals, extracting patterns, edges, colors, shapes, motion. You're not seeing the tree directly. You're receiving information about the tree and reconstructing a model of it in your consciousness. What you experience as seeing a tree is really your brain's interpretation of patterns of information. In fact, everything you experience is information. Every sensation, every thought, every memory. It's all patterns of information being processed by your brain and experienced by your consciousness. But it goes deeper than that. Some physicists argue that the universe itself is fundamentally made of information, that what we call matter and energy are really just different ways of organizing and processing information. Think about it this way. What is a particle really? It's not a tiny billiard ball. It's a pattern of quantum probabilities described by a wave function. And a wave function is essentially information. Information about where the particle might be, what momentum it might have, how it might interact with other particles. At the quantum level, the universe is built from information, and consciousness, in turn, is a system for processing information in sophisticated ways. Patterns within patterns. Here's where things get really interesting. Look at a map of the universe at the largest scales, billions of light years across. You'll see galaxies arranged in vast filaments and sheets, with enormous voids between them. It looks like a cosmic web, a network spanning the observable universe. Now look at a map of neurons in the brain. You'll see cells connected by axons and dendrites, forming intricate networks. Different regions connect in specific patterns, creating pathways for information to flow. The resemblance is striking. The cosmic web of galaxies looks remarkably similar to neural networks in the brain. Both are networks. Both process and transmit information. Both show similar statistical properties, similar patterns of connectivity, similar branching structures. This doesn't mean the universe is conscious in the way you are. The comparison shouldn't be taken too literally. But it suggests something profound, that the universe organizes itself into networks, into patterns of connectivity and information flow. And consciousness emerges from certain kinds of these networks. Perhaps consciousness isn't unique to brains. Perhaps it's one way, a particularly sophisticated way, that the universe processes information about itself. Quantum information. In recent years, a new field has emerged, quantum information theory. It studies how information behaves at the quantum level, and it's revealed some remarkable things. Classical information is built from bits, zeros and ones, yes or no, on or off. It's discrete, definite, either one thing or another. Quantum information is built from qubits, quantum bits that can exist in superposition. A qubit isn't just 0 or 1, it's both simultaneously, in varying proportions. And through entanglement, qubits can be correlated in ways that classical bits never could be. This gives quantum systems extraordinary computational power. A quantum computer can, in principle, perform certain calculations exponentially faster than any classical computer. It can explore multiple possibilities simultaneously, using superposition and entanglement to process information in fundamentally new ways. If the brain uses quantum information processing, as Alcor and related theories suggest, then it might have computational capabilities beyond what classical neural networks could achieve. It might be able to hold multiple thoughts in superposition, to process patterns of meaning that transcend classical logic, to generate the rich, unified stream of consciousness in ways that classical computation alone cannot. This remains speculative, but it points to a beautiful possibility, that consciousness arises not just from processing information, but from processing quantum information, from harnessing the strange properties of the quantum world to create subjective experience. You are a pattern. Think about your body. The atoms that make it up are constantly being exchanged with the environment. You breathe in, breathe out. You eat, digest, excrete. You shed skin cells. Over time, almost every atom in your body is replaced. Yet you remain you. Your sense of self persists. Your memories endure. Your personality continues. What persists is not the matter itself, but the pattern, the information, the way atoms are organized, the way neurons are connected, the way memories are encoded. You are not a static object, but a dynamic process, a pattern of information that maintains itself over time even as its physical substrate constantly changes. This is true at every level. Your cells are patterns, your tissues are patterns, your brain is a pattern, your consciousness is a pattern, perhaps the most complex pattern in the known universe. And if quantum consciousness theory is correct, this pattern operates at the quantum level. Your thoughts, your experiences, your sense of self, they're quantum patterns, emerging from the orchestrated collapse of quantum superpositions in your brain. You are information given form. You are the universe organizing itself into a pattern complex enough to be aware of its own existence. And that pattern, that information processing system called consciousness, connects you to the deepest nature of reality itself. This is consciousness. Not the content of your thoughts, but the experience of having thoughts at all. Not what you see, but the fact that there's something it's like to see. Philosophers call this subjective experience, or qualia, but you might simply call it being aware. Think about it this way. Your computer processes information constantly. It receives input, performs calculations, produces output, but there's nothing it's like to be your computer. No inner experience, no awareness watching from the inside. But for you, there is something it's like to be you. When you taste coffee in the morning, you don't just chemically process bitter compounds and caffeine. You experience bitterness and warmth. You might feel more alert, feel pleasure, recall other mornings. There's a felt quality to your experience. This is the easy part to understand. Consciousness is your inner world. Your thoughts, feelings, sensations, and experiences. The stream of awareness that flows through your waking hours and transforms into dreams when you sleep. Let's slow down even more now. Let's enter a space of quiet reflection. Because quantum consciousness theory, whether true or false, raises profound philosophical questions. Questions that humans have been asking for thousands of years. Are we the universe observing itself? Here's a thought that might make you pause. The atoms in your body were created in stars. The calcium in your bones, the iron in your blood, the carbon in your DNA. All of it was forged in nuclear fusion deep inside dying suns, billions of years ago. Those stars exploded in supernovae, scattering their atoms across space. Those atoms drifted through the cosmos, eventually coming together in a cloud of gas and dust that collapsed to form our solar system. The Earth formed, life emerged, evolution unfolded over billions of years, and now those same atoms that were once in the heart of a star are part of you. They make up your eyes, your brain, your consciousness. When you look up at the stars, you're not separate from them. You're made of the same stuff. You're the universe that has organized itself into a form capable of contemplating its own existence. The astronomer Carl Sagan put it beautifully. We are a way for the cosmos to know itself. If quantum consciousness theory is true, this connection is even deeper. You're not just made of the same atoms as the universe, you're connected to it through quantum entanglement. Your consciousness operates according to the same quantum principles that govern all of reality. You're not in the universe, you are the universe looking back at itself. Is consciousness fundamental? Most scientific theories treat consciousness as an emergent property. It arises from complex arrangements of matter. Neurons firing in specific patterns give rise to subjective experience. Consciousness is a product of physical processes. But some philosophers and scientists suggest the opposite, that consciousness is fundamental, that it's not derived from matter, but rather that matter and consciousness are two aspects of something more basic. This view, called panpsychism, proposes that consciousness, or at least some primitive form of it, exists at all levels of reality, that even elementary particles have some tiny spark of subjective experience, that consciousness is woven into the fabric of the universe, not something that magically appears when you arrange atoms in complex ways. This sounds strange at first. Electrons having experiences, atoms being conscious. But panpsychism doesn't claim that particles think or feel the way you do. Only that there's something, however simple, however primitive, that it's like to be a particle. Some basic property of existence that is the seed from which more complex consciousness grows. If this is true, then consciousness isn't something that needs to be explained by reducing it to unconscious matter. Instead, the hard problem dissolves. Consciousness has been there all along, at every level of reality. Your rich, complex consciousness is what happens when fundamental consciousness is organized into sophisticated patterns. Quantum consciousness theory sometimes resonates with this view. If consciousness is related to quantum collapse, and if collapse is a fundamental feature of reality, as Penrose suggests, then consciousness isn't just in your brain. It's a fundamental aspect of how the universe works. It's built into the laws of physics, ancient wisdom, modern science. Thousands of years before quantum mechanics, ancient philosophers and mystics explored similar ideas. They suggested that consciousness and the universe are not separate, that the self and the cosmos are one, that the boundary between observer and observed is an illusion. In Hindu philosophy, the concept of Brahman refers to the ultimate reality, the ground of all being conscious and infinite, from which everything emerges. And Atman, the individual self, is ultimately identical with Brahman. Your consciousness and cosmic consciousness are one. In Buddhism, the doctrine of interdependence teaches that all things are connected, that nothing exists in isolation. The boundary between self and other is permeable, perhaps illusory. Consciousness arises not from a separate self, but from the interconnected web of existence. In Taoism, the Tao is the way of the universe, the underlying pattern, the flow of existence. To be in harmony with the Tao is to recognize that you are not separate from nature, not separate from the cosmos. You are part of its unfolding. These ancient insights seem to echo what quantum mechanics and consciousness studies are now suggesting. That the universe is deeply interconnected, that consciousness plays a fundamental role, that the separation between self and world might not be as clear as we think. This doesn't mean ancient mystics understood quantum mechanics. They didn't. Their insights came from introspection, from meditation, from direct experience of consciousness itself. But perhaps they glimpsed something true, something that modern science is now approaching from a different direction. Perhaps the deepest truths about reality can be approached from multiple paths, through rigorous scientific investigation and through contemplative exploration of consciousness itself. And perhaps these paths are converging on similar insights. Whether or not quantum consciousness theory proves correct, it invites us to consider possibilities that expand our sense of what we are and what our place in the universe might be. Skepticism and scientific debate. We've explored the beauty and mystery of quantum consciousness theory. Now it's time to be honest about its limitations and the reasons many scientists remain skeptical. Science progresses through skepticism, through rigorous testing, through demanding evidence before accepting extraordinary claims, and the claim that consciousness is quantum is, by any measure, extraordinary. The warm, wet brain. The most common criticism of quantum consciousness theories is simple. The brain is the wrong kind of environment for quantum effects. Quantum effects are delicate. In laboratories, scientists need to cool systems to near absolute zero, isolate them from vibrations, shield them from electromagnetic interference. Even then, quantum superpositions collapse rapidly through interaction with the environment, a process called decoherence. The brain, by contrast, is warm. It's full of water molecules bouncing around. It's electrically noisy, chemically active, constantly interacting with its environment. It seems like exactly the wrong place for quantum effects to survive long enough to matter. Critics argue that any quantum superposition in the brain would collapse within trillionths of a second, far too fast to influence neural processing, let alone give rise to conscious moments that last fractions of a second or longer. Proponents of Aushore counter that microtubules might provide some protection from environmental noise, that their regular structure, their geometric organization, might create pockets where quantum effects can persist longer than critics expect. And some recent experiments suggest that quantum effects might be more robust in biological systems than previously thought, though this remains controversial. Lack of definitive evidence. Perhaps the most important point. There is no definitive experimental evidence that quantum effects in the brain give rise to consciousness. We have evidence that quantum effects exist in some biological systems. Photosynthesis, for instance, appears to use quantum coherence to transfer energy with remarkable efficiency. Birds might use quantum effects in their ability to navigate using Earth's magnetic field, but these are simpler systems than consciousness. And finding quantum effects in biology doesn't prove that consciousness is quantum. It just shows that quantum effects can persist in biological context longer than we once thought. To prove Aushore or similar theories, we would need to show that quantum processes in microtubules are necessary for consciousness, that disrupting these processes disrupts consciousness in specific, predictable ways. that the timing of quantum collapse events correlates with conscious moments. These are incredibly difficult experiments to perform. The brain is complex, consciousness is subjective, quantum effects are subtle. Separating quantum contributions from classical neural processing is an immense challenge. So far, we don't have that proof. The theory remains speculative. Alternative explanations. Many neuroscientists believe that consciousness can be fully explained through classical neuroscience, that we don't need quantum mechanics, that the brain's complexity, its network dynamics, its information processing capabilities are sufficient to give rise to consciousness. According to this view, consciousness emerges from the patterns of neural activity, from the way information flows through the brain's networks, from the global workspace created when different brain regions communicate. No quantum mechanics required. And while we haven't fully explained consciousness yet, classical neuroscience is making steady progress. We understand more each year about how the brain processes information, how it creates unified experiences, how different aspects of consciousness correlate with neural activity. Perhaps, skeptics argue, we simply need more time, more research, more sophisticated theories of complex systems and information processing. The mystery of consciousness will eventually yield to classical explanations. No need to invoke quantum mechanics. But here's where it gets interesting. Here's where the mystery deepens. Your brain is made of matter, atoms and molecules following the laws of physics and chemistry. Neurons fire in patterns. Neurotransmitters cross synapses, electrical signals cascade through neural networks. All of this can be measured, mapped, and observed. And yet somehow from all this physical activity emerges your inner life, your sense of self, your consciousness. How? This question is so profound, so seemingly intractable, that philosophers have given it a name. The hard problem of consciousness. The hard problem isn't about explaining how the brain works. Scientists have made incredible progress there. We can map which brain regions activate when you recognize a face, form a memory, or feel an emotion. We can even predict what you're thinking about by looking at patterns of neural activity, the importance of skepticism. It's important to understand these criticisms. Science isn't about believing what we want to believe. It's about following the evidence wherever it leads. And right now, the evidence for quantum consciousness is intriguing but far from conclusive. This doesn't mean the theory is wrong. Science has a history of ideas that seemed impossible at first, but turned out to be true. Continental drift, the Big Bang, quantum mechanics itself. Revolutionary ideas often face skepticism before evidence accumulates. But it does mean we should hold the theory lightly, stay curious, but also stay honest about what we know and don't know. Appreciate the beauty of the ideas while acknowledging their speculative nature. The truth is, we don't yet know how consciousness arises. We don't know if it's classical or quantum or something else entirely. The mystery remains, and perhaps that's okay. Perhaps the mystery itself is valuable. It keeps us humble. It keeps us wondering. It reminds us that for all our scientific progress, there are still profound questions at the heart of existence. Whether consciousness is quantum or not, whether or is right or wrong, one thing is certain. Consciousness is real. Your awareness exists, and that alone is worth contemplating with wonder. We've journeyed far together, through the mysteries of consciousness, into the strangeness of the quantum world, across theories and possibilities that stretch the imagination. Now let's come home, back to this moment, back to your breath, your body, your awareness, back to the simple miracle of being. Look up at the night sky, or imagine it if you can't see it. Those stars you see are ancient light, photons that began their journey millions or billions of years ago. They travelled through the void of space, through quantum fluctuations and cosmic expanses, just to reach your eyes in this moment. And here you are, aware of them. A tiny arrangement of atoms on a small planet, organized in such a way that you can not only see those stars but wonder about them, feel moved by them, create meaning from them. Is your consciousness quantum? That perhaps not. The truth is, we don't yet know. The quantum consciousness theory remains speculative, debated, unproven. It might be entirely wrong, or it might capture something profound about how mind and matter connect. But here's what we do know. Your consciousness is extraordinary. Whether it arises from classical neural networks or quantum computations or something we haven't even imagined yet, the fact that it exists at all is astounding. You are matter that has learned to contemplate itself. You are the universe looking back at itself with wonder. Through your eyes, the cosmos beholds its own beauty. Through your mind, the universe becomes conscious of its own existence. And whether or not your brain uses quantum effects, you are undeniably connected to the universe. Every atom in your body was forged in the heart of a star. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it was created billions of years ago in nuclear furnaces burning in the cosmos. You are made of stardust, literally. You are the universe, in human form, experiencing itself. So perhaps the deepest truth isn't whether consciousness is quantum or classical. Perhaps the deepest truth is simply that consciousness exists, that awareness is woven into the fabric of reality, that the universe has found a way through evolution and emergence and perhaps quantum mechanics to become conscious of itself. Rest in that mystery tonight. Let it fill you with wonder rather than demanding answers. Some mysteries are meant to be lived with, not solved. And consciousness, your consciousness, is perhaps the most beautiful mystery of all. As you drift towards sleep, or as you simply rest in this moment, remember, you are not separate from the universe. You are part of it, a wave in an infinite ocean, a note in a cosmic symphony, a moment of awareness in the eternal now, and that awareness you possess. That simple, irreducible fact that you exist and know you exist connects you to something vast. Whether through quantum entanglement or through more mysterious means, you are linked to every star, every atom, every moment of cosmic history. The quantum consciousness theory reminds us that reality might be far stranger and more beautiful than we imagine. That mind and matter might be more deeply connected than classical physics suggests. That perhaps consciousness isn't just something that happens in the universe, it's something the universe does. Sleep well if you're ready to sleep. Dream deeply, and know that whether awake or dreaming, you are participating in something extraordinary. You are the universe contemplating itself. You are the cosmos aware. Perhaps the greatest wonder of all is not that the universe exists, but that the universe has found a way to wonder about itself through you. Thank you for journeying with me tonight. Until next time, stay curious, stay amazed, and remember, you are the universe. becoming conscious of itself. One beautiful moment at a time. These are what philosophers call the easy problems of consciousness, though they're not actually easy at all. They're incredibly complex. But they're the kind of problems we can, in principle, solve through research and experimentation. The hard problem is different. It asks, why is there any inner experience at all? Why doesn't the brain just process information in the dark, so to speak, with no one home to witness it? Why is there something it feels like to be you? Imagine a robot designed to respond to pain. Touch it with something hot and it pulls away. Ask it and it says that hurts. Scan its circuits and you see activity patterns similar to pain centers in a human brain. But does it actually feel pain? Is there a subjective experience of suffering, or is it just an empty performance? With humans, as we're pretty sure the answer is yes, there is genuine experience. You know this with absolute certainty about yourself. You exist, you feel, you are aware. As the philosopher René Descartes famously concluded, I think, therefore I am. Your consciousness is the one thing you can be absolutely certain of, but explaining how consciousness arises from physical matter remains one of the deepest mysteries in science. Some researchers believe it's ultimately a matter of information processing and complexity. That consciousness emerges when a system becomes sophisticated enough in the right ways. Others suspect there's something more fundamental going on, something we haven't yet understood about the nature of reality itself. This is where quantum consciousness theory enters the picture. But before we can understand how consciousness might be quantum, we need to understand something about the quantum world itself. So let's take a journey into the very heart of matter, into a realm where the familiar rules of reality start to break down and where nature reveals its deepest strangeness. Let's enter the quantum world. Imagine you're holding an apple. Feel its weight in your hand, solid, real, substantial. Now imagine zooming in, past the skin, through the flesh, into the cells. Keep going, into the molecules, into the atoms, deep, deep down, past the electrons orbiting the nucleus, into the nucleus itself, into the protons and neutrons, into the quarks that make them up. You've now entered a realm stranger than any science fiction, a place where the solid, predictable world you know dissolves into something utterly mysterious. Welcome to the quantum realm. In our everyday world, things are what they are. A baseball is in your hand or on the ground, not both. A car is moving or stationary. You're in your kitchen or your bedroom. These seem like absolute, obvious truths. But at the quantum level, reality doesn't work this way. Down there, particles exist in multiple states at once. They can be in two places simultaneously. They can behave like both waves and particles. They can be connected across vast distances in ways that seem to defy the speed of light. This isn't speculation. It's not a hypothesis. This is what decades of rigorous experiments have shown us. The quantum world is genuinely, fundamentally strange, and the strangeness is real. Let's explore this strangeness gently, one mystery at a time. Wave-particle duality. Think of a wave in the ocean. It spreads out, rises and falls, can split around obstacles and recombine. Now think of a pebble, solid, localized, definitely in one place. These seem like fundamentally different things, right? Something can't be both a wave and a particle. It's one or the other. Except in the quantum world it can be both. Light, for instance, sometimes behaves like a wave. Shine it through a small slit, and it spreads out. Send it through 2 slits, and the waves interfere with each other, creating patterns of light and dark, just like water waves would. But other times, light behaves like a stream of particles, little packets of energy called photons. Hit a piece of metal with light, and you can knock electrons loose, one at a time, as if you were throwing tiny balls at them. And if tonight's story helps you feel calm or sleepy in the best way, a soft little like and maybe a subscribe would mean the world. It helps other tired souls discover this quiet corner too. Tonight we're going somewhere beautiful. Drop it into comments below. I'm always quietly amazed at how many of us are gently floating awake together across so many different time zones. Hello, and welcome to the Dreamy Science Lab, your peaceful little pocket of the universe where wonder feels soft and the night quietly cradles you. Before we slip into tonight's journey among the stars, I'd love to hear from you.